There are roughly 250 billion stars in the Milky Way galaxy. With about 2 trillion galaxies in the universe estimated, this makes us a grand total of 500 sextillion stars in the universe. They have been forming, burning and dying for billions of years in our universe. Among all of these large numbers, an interesting question to ask is, what is the largest star among them? What is the largest star we have ever seen? To begin the search for the largest star, we first need to understand stars are fundamentally different. Stars, during their life, go through a variety of different fusion forms to sustain themselves. As giant natural fusion reactors in space, they convert elements, hydrogen to helium, in their core. When a certain element is exhausted, the star switches to fusion of a heavier element, which goes on for a certain while depending on the star's mass. Depending on their mass and their process in stellar evolution, they can be any of a large variety of stellar types, from embryonic protostars to dead black dwarfs, and from failed brown dwarfs to the compact exotic stars. So an introduction to stellar types before answering this question is in place. The smallest type of star are the exotic stars. Exotic stars are the fusion dead remnants of large stars. They generally come in the form of black holes, neutron stars and white dwarfs. Since we won't count black holes as stars, the smallest of which are the highly compact and dense neutron stars, the remnants of really heavy stars. Neutron stars are the smallest type of star. At sizes of a mere several kilometers, no bigger than a small city, they are the remnants of truly massive stars which have burned out their fusion. When these stars collapsed, they were just short in mass to become a black hole. The smallest of these neutron stars is PSR J0348 plus 0432, an object discovered in 2007 and measured to be approximately only 26 kilometers wide. PSR J0348 plus 0432 is a member of a specific group of neutron stars called a pulsar. Pulsars are rapidly rotating remnants of the cores of massive stars. Moving past white dwarfs, which are a few thousand kilometers across, the smallest main sequence stars, which are stars that are in their prime fusion of burning hydrogen to helium, are red dwarfs. Red dwarfs are the stars that are just barely above the threshold to begin nuclear fusion in their core, and not to be failed brown dwarfs. Due to their small mass, red dwarfs burn the slowest, with an estimated life expectancy of over 20 trillion years long. Red dwarfs are the most common type of star in the universe. About 80% of all known stars is a small red dwarf star. The smallest red dwarf found is EBLM J055557 AB in 2017. It's about the size of Saturn, 120 kilometers wide, and meets the absolute bare minimum of fusion threshold. Above the red dwarfs we have the more massive orange dwarf stars. They range from about 800,000 to 1.2 million kilometers in diameter, and above them are the yellow dwarf stars. These are sun-like stars from about 1.2 million to 2 million kilometers wide on average. The Sun is a yellow dwarf at 1.392 million kilometers in diameter. Moving up we get to the F-class main sequence stars. These are stars like Procyon, which range from 2 to 2.5 million kilometers. Higher still we get to the bright A-class stars. They range from 2.5 to about 4 million kilometers wide and include the brightest star at the night sky, Sirius. Above this we get to the B-class stars. B-class stars can be from 2.5 to 16 times the mass of the Sun and have sizes from about 4 million to 10 million kilometers wide. Stars from this size and above have short life expectancies due to their fusion process going faster because of their mass. Above the B-class is the O-class main sequence stars. These are monstrous and rare stars. Only about 20,000 of the 250 billion stars estimated in the Milky Way are O-class stars. Stars of these class have 16 to 90 times the mass of the Sun and burn out their fusion cycle in about a few million years. They range in size from anywhere from 10 to 35 million kilometers wide. and were believed for a long time to be the most massive and large stars on the main sequence. But later we discovered the Wolf-Rayet stars, truly massive monsters which can go up in mass and fuse dead in less than 1,000,000 years. But since they are generally more compact, they aren't usually larger than any O-class star. To get to the truly large stars, we have to understand what happens when a main sequence star runs out of hydrogen to fuse. Depending on their mass, they continue to fuse helium to carbon. The heavier fusions release less energy and causes the star to swell and become a giant star. As the name implies, these stars are a lot higher up in the ranks of size. Subgiants are the smallest giant stars. They, in general, are stars that are still swelling. They can be stars like Pollux, around 30 million kilometers in size. The smallest giants are blue giants. They are the most massive ones and go from 10 to 70 million kilometers in size. Above them, the white, yellow and orange giants. Orange giants are smaller than the infamous red giants. From 30 to 50 million kilometers, they can be pretty modest of their size in giant terms. An example of an orange giant would be Arcturus. Above them lay the red giants. Red giants can go from the 50 million up to 300 million kilometers in size. 300 million kilometers is about enough to encompass the orbits of Mercury, Venus, the Earth and Mars. Due to this massive volume, these stars are increasingly less dense. Most stars end up a red giant, as will the Sun at the end of her life. And while red giants are truly sizable, larger still are the supergiants. Like the regular giants, supergiants come in the variety of blue, white, yellow, orange and red. The blue supergiants go from about 100 to 500 million kilometers in size, with an example being the Pistol star. As the red supergiants, like the infamous Betelgeuse, go from 300 million to over 1 billion kilometers wide. Stars of such size are well enough to swallow Jupiter's orbit whole. Their density drops significantly to not much denser than water, but for all their size, they too fall short in size of the largest class of giant stars, the hypergiants. Hypergiants are very rare and thus hard to find because they have a short lifespan because of their size. While the Sun has a lifespan of around 10 billion years, hypergiants will only exist for a few 100,000 years before moving on to the next stage in their evolution. The largest of the hypergiants are the red hypergiants. They are generally from 1 to 3 billion kilometers wide. So what is the largest of them? What is the largest star known? The answer is this one, Uyscuti. This monstrous star is located over 6,500 light years away in the constellation of Scutum. It's the largest star we have ever seen. It is enormous. It's over 3 billion kilometers in diameter. Its volume is an astounding 80 octillion cubic kilometers in volume. And with a mass of only 10 suns, its density is lower than that of the Earth's atmosphere. Uyscuti is over 2200 times the size of the Sun and only 10 times as massive. If it were placed inside the solar system, it would extend beyond the orbits of all inner planets, Jupiter, Saturn and even Uranus. Uyscuti was first catalogued in 1860. It's located a few degrees north of Gamma Scuti and northeast of the Eagle Nebula. Uyscuti is a dust-enshrouded red hypergiant and is classified as a semi-regular variable with an approximate pulsation period of 740 days. A star this large loses a lot of mass simply due to its enormity, explaining the surrounding dust cloud around the star. Still, the star is 340,000 times more luminous than our Sun, with a surface temperature of over 3,500 degrees Kelvin. At 3 billion kilometers in size, it's hard to imagine Uyscuti's size. But think of a plane traveling at the speed of sound. It would take, at its equator, over 900 years to circle the star. 900 years ago, the Knights of Templar were founded, and people were still crusading the Holy Lands on Earth. Even at the speed of light, it would take the plane over 9 hours to circle it, in contrast to 14.5 seconds around the Sun. Think about this for a minute and the immensity of the star start to become truly clear. But for all its size, Uyscuti is a dying star. Being on the hypergiant branch, soon it's going into meltdown. The fuel that is sustaining it is running out. The nuclear reactions that are powering it are winding down. We are watching its death throes. Eventually, the core will implode. The result? A new neutron star. For all its size, Uyscuti is only a tiny dot in the vast Milky Way galaxy in an even larger universe. Who knows what tremendous stars are out there, still unobserved, in the depths of outer space. The universe, with an estimated 500 sextillion stars, in April last year the Gaia 2 catalog had indexed 1.7 billion of them. This means less than 0.00000000034% of the stars are cataloged right now. These numbers truly show the immensity of the cosmos and how little we truly know about it. There might be stars with much more insane sizes than Uyscuti out there, waiting to be discovered.